Okay, so today we are going to talk about the coefficient of determination. So found on our calculator in the same spot that the R value is, but the coefficient of determination is R squared. So we're still talking about bivariate data with these scatter plots, and we have the response variable on the y-axis and explanatory variable on the x-axis. Okay, so what does the R squared value tell us? So if you have a look, the R squared value, or the coefficient of determination, is the degree to which one variable can be predicted from another linearly, so meaning following a straight line pattern, related to the other. So, and it's found by squaring all the R values. So that's what you do it. So say, for example, so if you look here, we've got an example here. So they're saying the correlation between the weight and height. So this is like what we were talking about yesterday. So we might put height would be the explanatory variable and weight would be the response. And we'd probably see the taller we get, the more weight we get. So they're saying the R value is 0.8. So what strength would we say that is? We'd say it's a strong. And it is, it's a positive number, so it's the direction is positive. So you know that. Now, if we square that number, you see you get 0.64. So 0.8 times 0.8 gives 0.64. So what we do, you're going to be asked to interpret the R squared value. So you now know it's 0.64. So you change that to a percentage just by timesing it by 100. And then you write this statement here. You have to write it this way to get your marks. Now, we always have our reference book, don't we? So there's no excuse for not writing this correctly. So if I was interpreting this example up here, I'd say the coefficient of determination tells us that, now I've times it, I'd say 64% of the variation in, now I won't write response, I'd write weight, yes? Is explained by the variation in, and what would I write there? Height. So that's what you would do. So what it's saying is, when you change the height, they're saying that 64% of it causes the change, roughly about 64% of change in the weight. So there's other percentages. The other 36% might be, there's other factors, isn't there? Diet, what makes someone's weight, whatever it is, yeah? So you can see there would be a pretty strong correlation. The taller you are, the more you weigh, but there's definitely other factors, and that's what that means. So you're looking for things like that in there. So, and you can see down here, I've written it out again, and I've shown you that instead of writing the response, you write exactly what that is, and you don't write the word explanatory variable, you write what it actually is. So, and then we just wrote here, if the R square is greater than 30%, we say it's got some significance. If you found that R squared was like less than that, really what you're looking at or investigating really it's not affecting it in a major way. We probably go look for something else in our studies. All right, so let's just flick to these next questions and have a look. So they've said calculating the correlation coefficient from the coefficient of determination. So this one is the R squared, and this one's R. So what they want to do is we want to go back, we're here, and we want to go back to that. Okay, so if they told me that R squared equals 0.5210, what's the opposite to squaring something? Good. So when I go to find it, I'm going to do the square root of 5210. Now, you have to remember, when you do the square root, it could be plus or minus. Because if you think about it, doesn't -4 times -4 equals 16, doesn't it? And if I say 4 times 4, doesn't that equal 16? So if I said the square root of 16, you really don't know which one I was talking about, do you? So you technically have to write plus or minus. But with this one, we do know. You have to decide, so you decide which one it is. And there is, it is, and there's a piece of information there that's telling me which one it is. This scatter plot over here has RV and EV. What direction is it? What type of R value would it have? It'd have a negative R value, wouldn't it? So that way we know that this is a negative answer. So you just do the square root of that. Does anyone know what that is? Okay, so we got R. We square root it and we get, I'm just going to do 2 decimal places. And we know it's negative from that diagram. Other ways we might know whether it's negative or positive, they might actually write it in the actual sentence. They might say this is a negative relationship, so you know, or they might say it's a positive, so you know for that. It's generally the negative that catches people out because most people default to the positive answer. Okay, so let's have a look at this next question. Data on the number of booze buses in use and the number of drivers registering a blood alcohol reading of 0.05 was recorded, and the correlation coefficient is found to be 0.77. Now, it's now asking me to calculate the coefficient of determination, so that's R squared. So all I have to do is go 0.77 and square it, and that will tell me what that is. Okay, so that ends up being, so the R squared is I'll just do 2 decimal places, 0.59. If there was a causal relationship, state the most likely variable to be the cause and the variable to be effect. So really what they're saying, which one is EV and which one is EV and RV. So let's have a look at it. The number of booze buses we're controlling, aren't we, really? So I'd say booze buses here, and then we're talking about blood alcohol here. Oh, God, I'll just write BAC, is it? Blood alcohol concentration or something. Okay, so it said it's positive, so you'd see a scatter plot like that. So if I went to interpret that R squared value there, I would be saying, so the coefficient, I'm using that template on the other page, the coefficient of determination tells us that 59% of the variation in the response, so which is, I'm going to say BAC, yeah, is explained by the variation in like number of booze buses or whatever it was, yeah? You just make sure you write the right thing. I'm being very shorthand there. Okay, so that's as simple as you'll get. So you're going to get questions where you're going to have to do the whole lot. They'll give you the 2 lists, create a scatter plot, determine which one's EV, RV, get a scatter plot, get the R value, and then get R squared and interpret it. So that's what we're up to at the moment. So I'll do a couple more questions. Okay, so here's another, this is taken from a couple of Year 12 exam questions, just to show you where you'll apply this. So the scatter plot below displays the resting pulse rate in beats per minute and the time spent exercising in hours per week of 16 students. So if you looked at this, there is 16 dots there, yeah? Because they took 2 pieces of information from all those 16 students. And they've put it on a scatter plot and they've done it there. So what one is the response variable? Which one is response variable? You guys tell me, which one's a response variable? Good. Resting pulse rate and this one is the explanatory variable. Excellent. So they have put that into the calculator and done all the things, and you see here they're saying the coefficient of determination is this. What I suggest you do when you read them and you see it's the determination, I always just put straight away above it that it's r squared, yeah? So that you don't get confused, because they do sound very similar. They look similar. So then they're asking me what is r. So I've got to find the r value. So I know to find the r value, I can do the square root of the r squared, but I have to decide which one it is. And which one is it going to be? Good, it's negative, because this is a negative relationship up here. It's going downwards. Okay, so when I see that, I can straight away eliminate those two and know that they're not correct. Sometimes that can make you quicker in an exam, because you might not even have to calculate it. But if we do the square root of that number, what is it? All right, so you'll find out that that is 0.913 whatever. So A. Okay, so this last question now. So here they are telling me the coefficient of determination. Now, they're saying 12.5% of the variation in life expectancy is not explained by human index. Can you see what they've done there? They're saying, I think I brought this to your attention so you could see is not explained. What percentage is explained? Yeah, so when we look at this, we know that 87.5% is explained. So when you're trying to work out what's not explained, it'll just be 100 minus that. And can you see that ends up being 12.5? Okay, so be careful with that. They asked that question. You just had to see the not word. Yeah, it's the other bit of it. All right, so in your workbooks now, you've got some questions that I want you to keep working through, so you guys can go and do that now.